G'day. It's been a while. As you can tell, the astute of you amongst you at least, those are overexposed gum trees back there. And last time you saw me, we were in the world of pine trees. I have moved with my family from America to Australia. It's been quite a journey, so I have not had the chance to upload a video in a couple of months, but I have had a chance to work with some electronic stuff that you see in the background. We shipped sort of our essential items, which I included electronic stuff in the first shipment. Our next shipping container should be here in a couple of weeks, and that'll include my machine tools, milling machine, lathe, and things like that. But it's been fortuitous that I've been working on electronics because my channel has grown a little bit over the intervening months of not uploading a video. And it's primarily people coming in to look at the videos that are covering analog electronics and analog video. And so that's been something that's been interesting to me, and I'm glad it's interesting to you too. So while I haven't uploaded a video in a while, I've definitely been doing stuff. The first thing I did was, while we were in sort of the armoured guard quarantine process that you have to go through to get into Australia, I did a new spin up of this board. This one isn't fully populated. This was the board that I shared with you a couple of months ago that takes 3 channels of HD component video in, separates out the sync, and then does a bunch of cool processing with some op amps along here to mess with the colors and to do voltage controlled modulation and things like that. And you know, I got this working, but I sort of got to a stopping point with this project because I was thinking about, you know, this has a fixed topography of how the op amps are all wired together. It would be cool to have flexibility and like route one op amp to another and you know, change the design without having to respin the board each time. And so I was thinking what I really need is some sort of crossbar switch where you have a bunch of inputs and a bunch of outputs and a n by n squared number of switches or amplifiers that let you route inputs to outputs, and that gives you complete flexibility. And I was hung up on building that because it would have been expensive and painful to build, and n squared is not a sort of problem you typically want to tackle. And I was listening to a podcast about politics and comedy called Election Profit Makers. Great podcast, you should check it out. And they were talking about Eurorack synth modules because, of course, that's what you talk about when you're talking about politics and comedy. And that got me thinking, maybe instead of building a crossbar switch, I could be a crossbar switch. For those of you who aren't aware, sort of Eurorack or modular synths have been around since the 70s. They're going through a huge resurgence right now. You get these little individual modules, maybe a voltage controlled filter, a synthesizer, an oscillator, a sequencer, and you sort of patch them together in different ways, and you can sort of design and build your own audio stuff like music, soundscapes, whatever, by patching cables together. I thought, it would be cool to do that in video. And there are definitely modules out there that play with sort of PAL and NTSC video, and they're cool, but I wanted to do my own things, and I was really focused on more sort of high-end, high control, high quality video signals rather than sort of the glitch RGB aesthetic that's pretty dominant. And so I started working on that board that I showed you and decided to take sort of a more modular approach. I built this guy here, which basically takes the components out of that board, but does some other things. And then what it does is it takes the luma channel in, which contains not only the luma in component, but also contains the sync signal, and it spits it out here on this port. But what it also has is a send and return. And what the send and return does is it just sends out the luma without the sync information, and it does DC voltage offset, so it's centered around 0. Then it reconstructs it on the input, adds the sync back in, does DC restore, and spits out a compliant signal out of here. And this is a cool little sort of modular bit of gear that allows me to do other experiments. The next experiment I wanted to work on is this board here, which I'm still sort of working on right now. I'll definitely cover this in my next video in detail. This is sort of like I want to do air quotes, color correction board. This is one channel. It has 14 knobs, 4 audio inputs, and it just takes one channel of component video and allows you to do a bunch of sort of linear and non-linear transforms to the video signal. You know, the heart of it is really doing log and sort of exponential curves that allow you to do interesting things to contrast. It doesn't do it symmetrically, so you can do the blacks different to the whites. You can change a bunch of stuff. This is more of a test bed board rather than something I'd see as being a useful board. It's got too much control, but I'll get into more of this in the next video. The other cool thing that's been happening is I've been chatting a fair bit with one of my viewers. A guy had reached out to me in July of last year because he was interested in this problem of dealing with sort of analog video, but for completely different reasons. He was interested in building a high quality analog to digital converter for sort of the retro computing / video gaming market. There are these devices that exist, that these are ones I use that do digital to analog and then analog to digital component to SDI in this case, which is a pro digital format. These things exist, but he wanted to build ones that deal well with the fact that a lot of these old computer games did weird things with the way they did syncing and the weird things about the number of lines they used. They didn't quite comply to the standards, but they could get away with it because analog TVs at the time were much more flexible than the sort of the rigid digital devices. And there's things to deal with sort of taking interlaced video and turning it into progressive video that works well on the web. So while these devices can be a component of that sort of signal path, he wanted to build dedicated devices for these, and we were chatting about that problem. Turns out he's primarily sort of I guess an audio engineer or electronics engineer who focuses on the audio domain. He does a lot of work with FPGAs and RF, doing sort of multi-channel distribution of high quality audio. And so this is a step up in bandwidth for him, but he has the skills to do a bunch of things that I can't do. And we started chatting about sort of taking the combination of these two devices and turning it into one. So you could have a box that takes HDMI in, spits out a sync separated component, again in air quotes, because we're going to violate the component standard in a couple of ways, analog signal that then lets you interface into modular video gear. And this gets us, and I'm going to go really deep on what all this means in future videos. I'm just giving you an overview of what we've been up to in this video, but this means that I'm going to have to get deeper into the world of FPGAs. So, there's another thing to show you. I got myself this guy here. This is the Nexus Video Development Board from Digilent. It contains a Xilinx RTX 7 series FPGA. That's this guy here. It has HDMI in, HDMI out, DisplayPort, USB, Ethernet, a bunch of really useful things for debugging video development. Now this chip is a pretty expensive chip. I think they're around $300–400. It has more logic cells than what we need for sort of this project, but the reason why we like it is it has 16 channels of high speed, like I think around 5 gigabits per second LVDS, which lets you do theoretically 4 channels of 4K HDMI video, and you can do some cool things with that. You can imagine something built around this or built around this sort of FPGA architecture would be a really interesting way to take sort of HD 12-bit video, bring it out to the analog domain, do cool stuff with it, and then bring it back into sort of Pro Tools like Resolve and really make use of the high bit depth and high quality that you can get from a device like this. So we've been chatting a fair bit. He's looped in a friend of his, Enrico, who does sort of systems integration and FPGA work. And the three of us are sort of working in our spare time to sort of solve Vittorio's problem of retro computing and my problem of doing weird shit with analog video, but in a high class, high quality way. And it's been a fun project. So this is sort of what I've been working on. I'm going to go deep into some of these other boards in upcoming videos. If you want to follow along in other ways, I've been sort of doing this under the brand name Superchromat. So if you follow Superchromat on Instagram, I'm doing sort of more stuff on there. But I'm going to try and upload some more videos here so you can get a sense of what we're up to. It's a lot of fun. It's cool stuff. I'll probably do my next video on this board because that'll give you a flavor of the sort of things that or at least I've been working on. And as we get more stuff out of Vittorio and Enrico, I'll be sharing you updates on the FPGA and analog to digital side. There's some really interesting challenges around sync separation and DC restore, getting really deep into the nitty gritty of how these signals work and how we can use and abuse them. But it's a lot of fun. Anyway, it's good to be back. I'm trying to keep this video under 10 minutes. So hi, speak to you all soon. Bye.